is Dr. P.Sreenivasulu, Head of the Department of ECE. I am here to tell you something about cellular and mobile communications, which is most important topic in advanced communication scenario today, because everybody is equipped with mobile phone, and I am here to tell you something about how the mobile phone works as well as how the cellular system works. Basically, if you look at the basic cellular system, like GSM or CDMA. GSM stands for Global System for Mobile Communications. CDMA, Code Division Multiple Access. Particularly here, in this lecture, I would like to concentrate more on GSM and its architecture. What are the main important blocks in GSM and its functionality. So let us start with your mobile phone. In a GSM standard, we call it as a mobile station MS. MS stands for mobile station, and it is called our mobile phone, where end user uses it. And the next level of GSM architecture, you will have BTS, base transceiver system, and this we call it as a cell site. And this base transceiver cell site or base transceiver system is provided with a set of antennas or set of radios, a power plant, a very big mast wherein different types of antenna systems are arranged, wherein we find directional antennas, omnidirectional antennas. Depending upon the type of system we adopt, like 60-degree sectorization, 120-degree sectorization, and all blah blah we will have. So, and then next level of GSM architecture, we will have main switching office, mobile switching office. MS we call it as a mobile switching office. So, there will be n number of BTSs. All these BTSs are interconnected with MS. MSC we call it as a mobile switching center. So, every individual BTS will have one unique identification code, and there will be a very high speed data link as well as voice link between all individual mobile stations and BTS. So, whenever we make a call, either from land phone or from mobile phone, whenever we make a call, that call will be connected first to the BTS, base transceiver system, and then in turn the base transceiver system will identify whether the call is from mobile station or from land phone. Depending upon that, the mobile BTS will take the decision whether the call should be routed to the MSC or directly to the nearest telephone exchange. If it belongs to mobile phone, and the request will be sent to the MSC, and the MSC knows very clearly where the mobile is. There will be two things, one is called party, second one is calling party. Calling party is myself making called party one of my friends with whom I would like to talk. For example, my friend is at Hyderabad, I am here at Gudur, I would like to talk to him. If I make a call from here, my call first will be routed through wireless media to the BTS station, and the BTS station will analyze whether this call belongs to mobile or from a mobile station, and the call party is like to whom which I would like to talk, whether that particular number belongs to base station, land phone or mobile station. Depending upon that, BTS will send a request to the MSC, mobile switching center. The mobile switching center will take the appropriate decision, because if you make a call to a friend who is at Hyderabad, in Hyderabad, which base station he belongs to at that particular instant of time, and that information will be available to the MSC, and the same information will be sent back to the concerned BTS from where the call is originated. Now, the entire process, two things we have to consider. One is wired communication and second one is wireless communication. So, if you look at cellular communication system as a whole, wireless communication will be very less. That is always air interface. We call it as air interface. Air interface will be starting from your mobile station to the BTS. The rest of all is wired communication. Because if we consider the differences between wired communication and wireless communication, wired communication is very safe and very less prone to noise. And if you look at wireless communication or air interface, what we call it as, it is prone to noisy, and there will be different kinds of noises will be added to that. There will be a very big problem in recovering at the receiver. So that is the reason, though we call it as a wireless communication, from mobile station to BTS, only there will be a wireless communication. We call it as a air interface. From there to till the base station wherein your friend is, in between these 2 points, completely wired communication. Probably we are making use of optical fibers communication system over here to transmit this either voice, data or video signal. Now, this is what the scenario, how the call will be established between 2 parties. When it comes to the different types of fading effects in mobile environment, because when we make a call as an engineer, when we make a call, if at all you want to design a system for cellular communication scenario, we should have a very clear idea where you are going to establish your communication system, a cellular system. And you should know the clear idea about what type of terrain it is, and what type of soil it is, and what is the water bodies, and what about rest of the trees and their heights and trunks and all, because all this comes in to the picture while we are transmitting the signal, particularly depending upon the, because when these cellular mobile communication signals are transmitting, there will be a different paths, like we can say multiple paths. So because of that multiple paths, I can say different path lengths with the different distances, they will be reinforced or superimposed at mobile station, or maybe at MSC, or maybe at the end user of mobile station or base station. So when these different signals traveling with the different path lengths, because of the different phase differences, so these signals gets sometimes may be added up, some other times may be subtracted, so that we will have a fading effect. This fading may be short-term fading or long-term fading. We come across different types of fading effects. This all depending upon the type of soil, water bodies, trees and all. So there will be a huge loss, particularly when we are talking about foliage. Foliage means have a very big trunks, and if you go to the Bangalore, from Chittoor to Bangalore, if you go to we find very big trunks. Particularly when we are traveling through that particular path, when we make a call, there will be huge loss of signal. Then how to come out of it? This is another big challenging task while we are designing this mobile environment. So this is one aspect. Second one is why this cellular system became so popular when compared to the conventional mobile telecommunication system. This is to be addressed. Everybody should know very clearly. In the olden days, we used to have a mobile telecommunication system, but we don't have any cell site mechanism. We don't have any frequency reuse concept. Because of this frequency reuse, see why? Because I would like to emphasize here why the cellular system became so popular, because of majorly 2 issues. One is frequency reuse concept, and second one is handover mechanism. Handoff, we call it as a handover mechanism. So when we make a call, and assume that you have initiated your call and you are moving by car or by vehicle, you will be passing through different cell sites. When you make a call, you will be assigned a strong frequency channel. I would like to tell you very clearly what this frequency channel means. A frequency channel consists of 2 different frequencies. One is from mobile station to the base station, I mean to say MS to BTS, and second one is from BTS to MS. It is a bidirectional communication. We call it as a full duplex communication. So we will be talking as well as we will be listening simultaneously. This is what bidirectional communication system. So channel means there are 2 different carriers will be assigned. They are set apart to avoid interference between talking and listening. Anyway, this is one aspect. The second one is when you make a call from base station 1 and assume that you are moving by car and you are passing through different cell sites. How your call will be continued. That's another challenging task in cellular communication system. So whenever you are moving, there are two different handover mechanisms or handoff mechanisms. One is mobile assisted handoff and second one is network assisted handoff. We call in brief MAHO, mobile assisted handoff. Second one is network assisted handoff. Particularly if you talk with reference to network assisted handoff, mobile has got no intelligence. Entire call handling and billing activities and all will be taken care by the network. It's not your individual mobile phone. So the problem here is that mobile in the olden days we used to use this network assisted handoff. We used to use the network assisted handoff because the major problem with this network assisted handoff is that the network, whenever the number of calls, the number of subscribers are increasing, as the number of subscribers increasing, loading on the network is more. As the loading on the network is increased, it is very hard to handle the load. So that is the reason why now what the cellular designers done is, they have provided a kind of intelligence to the individual mobile station, I mean to say mobile phone, and now this network is no way concerned in handling this call handling, handoff and all. Now what I would like to tell you here, the mobile phone is provided with a kind of intelligence. It will take care of where to go and which station is nearby, which cell site is nearby, and all will be monitored by the mobile station itself. I would like to tell you why this mobile assisted handoff becomes so popular today in cellular communication system. Whenever you make a call and assume that you keep on moving by car, your phone will be able to process your call as well as at the same time it will monitor the nearby cell sites. Nearby in the sense neighboring cell sites in the first tier. So it keeps on monitoring the signal strength. It keeps on monitoring the signal strength from the nearby cell site while it is moving before it is moved out of the cell site from where the call is initiated, and it will be monitoring the mobile station. Mobile station knows very clearly to which BTS I am going to enter. So the same information will be conveyed to the BTS that I am going to enter into you. Will you please hand over my call to some other frequency channel? So the same information will be in turn sent to the mobile station, I mean to say MSC. Okay, so MSC will give a control. MSC will give a control to the BTS, and BTS will hand over the call. What I would like to tell you here. So here, no way network is involving in call handling. I mean to say that the decision will be taken by the mobile station itself. It's not the network. So mobile station is suggesting to the network saying that I am going to enter this particular cell site. Will you please provide me the call continuity? The same information will be sent to the MSC, and the this BTS will get a confirmation from the MSC, and the call automatically will be continued. Now, see, when it comes to the different types of handoff mechanisms, as I told you, this is one classification is mobile assisted handoff, and second classification is network assisted handoff. I told you something about it, and there are again two different types of handoff mechanisms. One is soft handoff, and second one is hard handoff. Hard handoff is actually happens in GSM system, whereas hard handoff is in GSM, soft handoff is in CDMA. Now, what is the difference between hard handoff and the soft handoff? Whenever you make a call and you assume that you are moving by car or any vehicle, right? Whenever you are going to enter into some other frequency site, I mean to say new cell site, your call, it is true that you are adopting your mobile assisted handoff mechanism, no doubt. Whenever you put a request to the nearest BTS and in turn to the MSC, one of the frequency channel from the home cell site where you have initiated call will be terminated, and another frequency channel from the candidate cell site. Candidate cell site in the sense wherein you are going to enter. So from that particular cell site, you are going to assign one of the another frequency channel, right? Now, what is happening is the initially assigned frequency channel will be terminated, and another new frequency channel from the candidate cell site will be assigned to you. Now, such a way that your call will be continued. Actually, what is happening is call physically dropped, but the gap between termination and reinitiation of the call will be order of microseconds or nanoseconds. An ordinary human cannot identify that microsecond period. So, why it is called hard handoff is physically your call will be terminated and reinitiated by the system, not by you. You feel that the call is continued, but actually your call is terminated and reinitiated. That's why it is called hard handoff. When it comes to the soft handoff, it is happening in CDMA. CDMA, I told you, CDMA stands for Code Division Multiple Access. So it was introduced by Reliance Communications in India first in 2.5G, 2.5 generation cellular communication system. It became so popular, and most of the world is rushing to use this CDMA technology now, narrowband CDM, wideband CDM and all. When it comes to the soft handoff in CDMA mechanism, in CDMA technology, so in a CDMA, one of the particular code will be assigned to you whenever you initiated a call. Whenever you initiated a call, one of the particular code, we call it as a waltz code, and the waltz code will be assigned to you, and the same code you will find nowhere in India. That's the uniqueness. Code division. For every individual call, one waltz code will be assigned. Here, the same frequency. When it comes to the GSM, as I told you, whenever you initiated a call in cell site 1, whenever you are moving into the new cell site, some other frequency channel will be assigned. But such is not the case in CDMA. In a CDMA, actually what will happen is only one frequency channel. It's not that the channel, it is about code. So anybody can, the beauty of the CDMA is that anybody can use any frequency channel, but the same frequency channel will be used by n number of users, but with different codes. That's the beauty of the CDMA. So here, whenever you assign one particular code, though many n number of users are using the same frequency, doesn't matter where you are, whether you are in the channel cell site 1, cell site 2, cell site 3, doesn't matter. There is no need of termination of the call and reinitiation of the call. So that is the reason why, so this CDMA became so popular. One major issue. One major issue with reference to the CDMA is that as the number of users increases, background noise level will be increased. So such is not the case, because why background noise is increased in a CDMA when compared to GSM? GSM, such is not the problem in GSMA. In GSMA, when you make a call, you will be assigned with one particular frequency channel. The same frequency channel will not be assigned to any one of the users in India. Something like, at least in the vicinity. So the frequency channel may be used somewhere, maybe after a few kilometers, but in the vicinity, maybe what we call it as a frequency reuse distance, like within that region, the same frequency channel will not be assigned to any another user. So there is no such interference. But in the case of CDMA, the same frequency channel is used by the n number of users with different codes. So as the number of users, as the number of subscribers or the users in a CDMA system increases, the noise level is increased. Then this is another challenging task to be addressed in CDMA technology. Right. When it comes to the near and far end problem in GSM and near and far end problem in CDMA particularly, so whenever near and far end means we have a cell site over here, a big mast and different types of antenna systems like omnidirectional antenna, directional antenna with 60-degree sectorization, 120-degree sectorization, and all different inner outer lay, inner lay, like different type mechanism at different heights. We will have if you look at the mast of the cell site antenna system, you will find at different levels we have a different antennas. Okay, so you keep it aside. When I make a call, I am talking with reference to particularly mobile. When I make a call, if the calling party is very near to the cell site, and some other time the same calling party is far from the cell site, two issues comes in picture. One is a calling party, myself is making a call, say I am very close to the cell site, and some other time I have initiated a call and myself is far from the cell site. Now what is the situation to be addressed? What are the general issues we generally come across? Now problem is that whenever myself is very near to the cell site, so I will receive very strong signal from the cell site. In the second case, whenever I am far from the cell site, maybe at the edge of the cell site, maybe my cell site radius is 2 kilometers, I am away from the cell site, it's nearly 2 kilometers from the cell site, I will be receiving very weak signal, right? So this is the two cases. Now what this BTS has to do is, so I am very nearer to the cell site, I am talking to one of my friends, from my mobile phone, the BTS will receive the very strongest signal, and a fellow who is at 2 kilometers away from the cell site will receive the very weakest signal. Now one signal from the fellow who is at very near to the station, and second fellow who is at far from the cell site. Now these two signals are traveling nearby. There will be a channel combiner, 16 channel combiner or like 32 channel combiners. We have different types of channel combiners, so we will see later about it. So whenever a weak signal is traveling nearby, whenever a strong signal is traveling, though they are two different frequencies, we call it as the strong signal will be interfered with the weak signal. So this kind of interference, what we call it as a non-co-channel interference. So this is another challenging issue in GSM technology. Such is not the case because in a CDMA we don't have different frequency channels. The same frequency channel will be assigned to n number of users, and code will be different, right? Now when it comes to the GSM, this is the major challenging problem. What I am talking about is near end and far end problem. Near end and far end problem. So a fellow who is very near to the station, he is speaking to one of his friends. The mobile antenna, antenna which is at mobile station or BTS will be receiving very strong signal. Fellow who is at far off, 2 kilometers away from the base station, will be receiving weakest signal, and these two signals are traveling side by side. The strong signal will get interfered with the weak signal, so that the weak signal fellow gets interfered. Such is the case. Now what we have to do is the signal which is coming from the nearest station should be get suppressed, and the signal coming far from the mobile station should be increased. And if you look at any instant of time, when these two signals are traveling side by side, their power level should be same, so that they will not get interfered with each other. So this is what I would like to summarize what I discussed today. One is, what is the major difference between GSM and CDMA? What is the cell site mechanism? What is MS? What is